Now we are going to talk about the lazy iterables. So till now we have discussed that the iterable is an object that returns the iterator, and iterator is also the object that call itself or the return itself when the iter has been called. And when we ask for the new value, it calls the next method, right? Till now we know this. So now let's talk about lazy evaluations. So the lazy evaluation is when evaluating a value is totally different than until is being requested, right? So it's like evaluating a value is deferred until it's actually requested. That means it's not specific to the iterable. So this concept is not specific to the iterable as well, right? So here, let's call a simple example of the lazy evaluation to understand this concretely, right? So here we have this circle class which we set the value of radius. We have the radius method to get the radius value. This is we are using the property decorator so that we can use this radius method as an attribute. And now we have now if you set the, like, this is the method we have used to set the property of radius. But when we set the property of radius, right, it will calculate the area of the circle, right? We are calculating this area of circle directly over here. Let's call this, or let me just clear the output. So let's run this. Now let's create the object of the circle. When we call the area, we are able to get the area value over here. This has been predefined. So predefined means when we create the object, this thing has been calculated. When we set the radius, and again when we check the area and the radius, now this area has again the recalculated, right? So here, as we can see that every time we set the radius, we recalculate this and store the area value, right? And when we request the area of the circle, we simply return the stored value. Here, when we call the area, it is returning the stored value. But when we change the value of a radius, we recalculate the area value. But instead of doing this, we could just calculate the area every time when it is requested without storing the value of area. So that means it's like whenever there is a need of the area, we can calculate the value of area and then we can get the value of area. We do not need to pre-calculate when we change the radius or give the radius value. Here is the different version of the same code. Here every time we have this radius, we are changing the radius, but now we have the area method which calculate the area of circle based on the radius or based on the given value. So now this, whenever we need the area, now we'll calculate the value of area. It's not like it's pre-calculated over here. So let's see this here when we create the object. Now when we call the area, this means that it will call this method and it will calculate and give the output. This is totally different than what we have done earlier. When we change the area, again we'll calculate the area value, right? But the area is recalculating every time, right? So we may take the hybrid approach when we want to store the area. So this is the different approach and this is the different approach. But we can also take the hybrid approach when we want to store the area. So we do not need to recalculate it every time, right? So it will recalculate only after when the radius is modified, right? So here is what we are doing over here in this code. First, we are setting the area as a none value. And then we are checking that if the area is none, then we only want to calculate, right? We can run this. Here we have this, we have created the object. We can, when we call 8c.area, now currently the area value is none, so it will call calculating area. We can see that then we have calculated the area. But when we again call the area the area attribute, but this time when we run this, the area is not none. So it will return the same value. right? So this is the hybrid approach. If the value is not available, we'll calculate it. If it is available, so we'll simply return it, right? We can, if we set the radius, here we are setting the radius, and when we again calculate the area, we are again getting the, we are again calculating the area. When we set the radius, the area become none, right? This is called the lazy evaluation. This technique, hybriding both, is called the lazy evaluation. We do not actually calculate and store the attribute of the class until it's actually needed, right? And we can sometimes do similar with the iterables, right? Sometimes we do not actually need to store every item of the collections, right? And we may be able to get the calculated or calculate the items whenever there is a needed. For example, consider this over here. So here we want to iterate over the factorial of integers starting with the 0. So we want to calculate the factorial of 1, 2, 3 till n. So here is the one implementation we have. We have the factorial implementation. Here we have the iter method. In the iter method, it returns the factorial of iterator. That means the, again, we have created the iterator over here. So this iterator class we have created, which will calculate the factorial of the value using math.factorial, right? And then we are using the, we have all the implementation over here in the fact iter. We also have the iterator method, right? So now we have the class. Now we can create the object of it. We can check the list of factorial over here, right? And where we call this, we'll get this value of the all the factorial between 0 to 5. So we can see that we do not store the value of the iterable over here every time when we call that, right? Instead, we just calculate, like every time when we call the next, we are calculating the factorial. We are not storing prior the value, right? In fact, now that we have this iterable, we do not even need it to be finite. Like here, we have built it to the finite. First, we created with the value 5, right? So this is the finite of factorial object we have created. But when we remove this length needed, right, all these values, so it can be infinite over here. We can see that here we have removed the length object, length attribute, right? And now every time when we call it, it will calculate the factorial, and that's it, right? Here we have the factorial object. We can create the iterator. Now we can loop it over 10 times. We are creating the factorial between 0 to 9, right? So this is what the lazy iterable is, right? Thank you very much.